I have the pleasure of presenting ASMSpotter to you, an AI software to monitor and track changes in open-pit artisanal and small-scale mine sites from satellite imagery. The pictures you see here show how the ASMSpotter works. The first image is the plain satellite image. The second shows the ASMSpotter predictions of where ASM gold sites are, and the third image shows changes in ASM activity detected over time. ASMSpotter originated from a project funded by the European Space Agency and carried out by the Berlin-based AI software development company DIDA and the Institute of Mineral Resources Engineering from Aachen University in Germany, in which the technical and commercial feasibility was investigated in the northeast of Suriname. The results showed that 80 to 90% of ASM gold sites could be detected by applying AI image segmentation algorithms like convolutional neural networks. In the course of the project, DIDA contacted us at Levin Sources to team up with ASM specialists in order to make sure that the solution is handled responsibly and to increase the chances of it becoming part of ASM formalization programs by mining authorities in various countries, which are often partly financed by international donors like the World Bank. The consortium took part in this challenge and applied for additional funding from the European Space Agency in order to pilot the service in one of the major ASGM markets in Ghana, to expand the training dataset to all major ASGM geographies and to create an easy-to-use user interface. A letter of endorsement from the Ghanaian Ministry of Lands and Natural Resources has been obtained, and the consortium is very eager to bring ASMSpotter to the next level. This means creating an AI solution to support government authorities in the establishment of responsible mining practices, creating wealth and health for mining communities and the environment. We are a unique team composed of machine learning specialists from DIDA, mining engineering experts and geologists from the Institute of Mineral Resources Engineering, Aachen University, and ASM experts from Levin Sources who have worked in ASM formalization across the world. The motivation for the team to come together was to use our diverse skill set to contribute to an environmentally friendly and socially responsible ASM sector, which offers sustainable livelihoods to miners and their families and communities. The ASMSpotter is the first machine learning software to automatically detect artisanal and small-scale gold mining sites from satellite imagery. It makes ASM monitoring more efficient, systematic, and cost-effective, thereby supporting formalization and regulatory efforts to improve social and environmental outcomes of ASM. Users are mining or environment agencies in countries with ASGM sectors, and customers are multilateral donors and development agencies who fund ASM formalization activities. What is the problem we are tackling? The problem is threefold. On the one hand, a lot of countries have widely unregulated ASM sectors that can negatively impact on the environment and on human health, safety, and dignity. Second, many countries encounter challenges in monitoring ASM and therefore managing ASM in a way to improve social and environmental outcomes. This is due to widespread informality, remote locations, and rapid changes in location of the mine sites, and also due to limited financial and human resources of mining agencies. And third, current monitoring solutions rely heavily on manual analysis of satellite imagery, the use of drones, or in-person visits, which are time-intensive, expensive, and pose security risks. The ASMSpotter offers part of the solution. It permits rapid automated analysis of a large volume of satellite images over large geographic areas. It thereby decreases the cost of monitoring and frees up resources for other formalization activities like training or support services. It increases the ease of data collection, and it allows monitoring in real time, meaning every 14 days, and therefore leads to better informed policymaking. It also allows to focus site visits on the most important ASM hotspots. And finally, by accompanying the technical solution with consulting work on ASM formalization, we aim at ensuring that the ASMSpotter not only benefits agencies that are aiming to regulate and formalize the sector, but also the miners themselves, ensuring that they receive the support they need to enter the formal economy, work in dignified conditions, and earn a stable livelihood. Who are the users and customers? The users are government agencies that are seeking to monitor, manage, and formalize the ASM sector more effectively. They often have restricted financial resources and are therefore looking for cost-effective solutions. They have a high technology awareness and are in need for easy-to-use technologies. Customers are development agencies and donors that are funding a variety of ASM formalization activities, including remote sensing. They have limited budgets and therefore wish for cost effectiveness. And they also wish for long-term sustainable solutions. What are our impact projections? In Ghana, there are around 1.1 million people working in ASM, of which 70 to 80% are informal. Current negative impacts of informal ASM in Ghana, as in many other countries, are deforestation, water pollution through the use of chemicals or sedimentation, and human health impacts, either because of the use of hazardous substances or because of inadequate health and safety measures. Our impact projections of this pilot project in Ghana for the next 3 to 5 years is that the ASMSpotter will allow the Ministry for Lands and Natural Resources to better detect informal ASGM activity and target interventions, thereby leading to the formalization of 5% additional ASGM miners and mitigating the impacts of 10% additional informal ASGM miners on biodiversity, water, and human health. I will now hand over to my colleagues at DIDA to finalize the presentation.
Starting with the competitive landscape. So actually, we've seen a couple of competitive solutions, for example, developed by remote sensing solution providers like GAFAG, GeoVille, and so on. But those solutions are basically project-based, and there's no automatic solution, but only a kind of a map of ASM sites at one point in a time. A second competitive offering is actually Delft Database or COPX, where it's actually they actually rely on third-party data integration, so people on the ground contributing data, statistics, and so on, but there's no real solution towards monitoring and satellite imagery. And enhanced monitoring solution, which is actually something that is focusing on environmental damage, but no machine learning is applied and no interface for local authorities is provided. So actually, we believe to be the first AI solution for monitoring ASM sites with remote sensing data like Sentinel-2 data. And what we believe is the biggest advantage is actually that the update circles are quite small. So we actually are talking about short intervals of 5 to 14 days. And we believe that that ASMSpotter makes ASM monitoring automatic, reliable, time-efficient, and cost-effective, and could actually replace or complement manual remote sensing solutions and be integrated into all major ASM formalization programs. One of the biggest advantages actually that we had already a project with the ESA working on this, and that the solution is already working for most relevant ASGM countries. So actually, for example, in Indonesia, in Ghana, in most northern Latin American countries around the equator, where lots of where the areas are forested, the solution actually works already quite well. And one very central competitive advantage is actually that we already have a training data set with more than 10,000 labeled images generated for the Suriname. So what is the business model? So who are the agencies who should pay for the service? It's actually development agencies like the World Bank, like the UN, OECD, GIZ, or government agencies like the Ministry of Lands and Natural Resources or comparable institutions in different ASGM geographies. Channels of distributions could be ASM consultancies, could be, of course, development agencies who have a couple of formalization programs, but of course also conferences, the network from Levin Sources, but we'll also do content marketing where we, for example, provide screenshots or analyze satellite images over different geographies and therefore trigger some interest in the solution. The costs are basically human resources. We believe that a team of 6 people, 3 of them being machine learning scientists, will be enough. to maintain the service, and for each new project, a production installation cost of pretty much $25K will probably be enough. Source of revenues are the yearly license fee and the consultancy service in the governing and training on using the software. Go-to-market is actually that we need to develop some marketing messaging for the key audiences. We'll develop an accompanying government consultancy service kit, but of course we'll also do public tendering processes where we actually apply to become part of a formalization program with our remote sensing component. And in the end, we'll negotiate the agreements with customers and users. What are the risks? So, one risk is actually that the training data set is not enough to cover other areas like the Ghana area. We actually tested this already and have accuracy of more than 80%. And also we'll extend the training data set to cope with that and do some ground truthing so that we actually can be sure that indeed the ASM mines showed on the image. And of course it might be that government institutions lack the financial means. That's why we try to leverage funds through development agencies. The technological skill set also needs to be accurately, and for this we'll provide training, but also create a very easy to use interface. And of course it might be used for unintended ends. And for this, we'll again provide training and give governance and formalization advice. What have we already accomplished? We've already completed a project with the European Space Agencies, and we developed a machine learning model, in this case, a UNet, convolutional neural network, with the PlanetScope as a data source. We adapted that to Sentinel-2 at a later stage. And with that, we already are able to detect 75 to 90% of all sites, depending on the size. Of course, smaller sites do not have the same accuracy as larger clusters. We conducted a lot of in-depth interviews with more than 20 industry experts and intermediaries, and we got a letter of engagement from the Ministry of Lands of Natural Resources, which actually stated that they have a problem monitoring large geographical areas. So what are the next steps? We try to raise additional funding from the European Space Agency, from the European Partnership for Responsible Minerals, to create a user interface and to build a strong reference case in Ghana. We'll do select some pilot areas and run workshops with the Ministry of Land and Natural Resources in Ghana, and we'll expand the training data set and improve the model performance to expand ASMSpotter to all major ASGM geographies.
Mainly, we will use Azure Compute for research and development, as deep learning and computer vision require a lot of computational resources, such as GPUs. DIDA, as a small and young company, does not maintain its own infrastructure, but relies on cloud-based solutions. Additionally, we have used and will use Bing Maps for validation of the training data set. And while the main data source will be the Sentinel-2 satellite system, Bing Maps images may be integrated as well. In production, ASMSpotter will be deployed in the cloud, as the customers probably won't have their own infrastructure either. In the cloud, ASMSpotter can be run on demand if it's used as an analysis tool, or continuously if it is used as an early warning system. For mission planning, that is the dispatch of controllers on the ground by the respective mining ministries, ASMSpotter's UI can make great use of Azure Maps. This was our pitch. We hope you enjoyed it, and thanks for the opportunity to present ASMSpotter.